All right, so we have this question here. It says 65 students took part in a quiz competition. The results came out as follows. So we have 15 passed quiz 1, 21 passed quiz 2, and 27 passed quiz 3. In addition, 7 passed quiz 1 and quiz 2. 8 passed quiz 1 and quiz 3. 9 passed quiz 2 and quiz 3. 5 passed all the 3 quizzes. So I'm saying illustrate this information on a Venn diagram. So we have that 65 students took part in a quiz competition. Then they're telling us that 15 of these managed to pass quiz 1. Then 21 managed to pass quiz 2. And I have that 27 managed to pass quiz 3. Then they're telling us 7 passed quiz 1 and quiz 3. So these passed quiz 1 and quiz 2. Then 8 managed to pass quiz 1 and quiz 3. Then 9 passed quiz 2 and quiz 3. Then they're telling us that 5 managed to pass all the 3 quizzes. That's quiz 1, quiz 2, and quiz 3. Okay, now they're telling us to illustrate this information in a Venn diagram. So I'll draw my Venn diagram here, like that. Okay. Then I'll have one set for quiz 1, for quiz 2, and for quiz 3. So say this one is quiz 1, then we're saying this is quiz 2, and we say this one here is quiz 3. And we have the universal set here, which is everyone that took part in the water in the quiz competition. So they're telling us 65 took part, which means when we input everything in our Venn diagram, the total number we must have when we add all our numbers must be 65, because 65 students took part in a quiz what competition. So now where we start from? We start from the ones that took all of them. So they're telling us that 5 passed what? Passed all the 3 quizzes. So meaning here where all the 3 sets intersect, we'll put our 5 like that. Okay, then we can move on to quiz 1 and 2. So here they're telling us 7 passed quiz 1 and quiz 2. Meaning in this intersection here, where we have quiz 1 and 2, we must have 7 people that managed to pass. So we're seeing here that 5 passed all the 3, and here the intersection of quiz 1 and quiz 2 must be 7. So meaning to just get the value of here, that part there, we must subtract 5 from 7. So that will give us 2. So we get 2, so will be 2 here. Such that when we add these two numbers here in this intersection of quiz 1 and quiz 2, we'll get the 7 which they're talking about. So 7 managed to pass quiz 1 and 2. Then we go on to quiz 1 and 3. So quiz 1 and 3 is from here to there, this intersection here. So they're telling us that 8 managed to pass both the quiz 1 and quiz 3. So we already have 5 here, meaning when we say 8 minus 5, we'll get 3. So here we must have 3, such that this intersection between quiz 1 and 3 gives us the 8 that managed to pass quiz 1 and 3. Then we have quiz 2 and 3. So quiz 2 and 3, it's here, and there, quiz 1 and quiz 2 and 3, they're telling us that 9 passed. So 9 minus the 5, we get 4. So here we will have 4. This here, then when we add these two numbers, 5 and 4, we get the 9. They're telling us that 9 managed to pass both quiz 2 and 3. Now, next we check how many passed only quiz 1. They didn't pass any other quiz, but they only passed quiz 1. So the way we do that, we have to add these three numbers here. So we have to add these three numbers. These numbers here, 2, 5, and 3. So you add 3 plus 5 plus 2, like that, then minus. So you check how many took part in quiz what? Quiz 1. And they're telling us that 15 took part in the entire quiz what? Quiz 1. So meaning we'll say 15 minus what we got, which was 10. And this here gives us 5. So it means 5 managed to pass only quiz 1. Then we go on, we do the same for quiz 2 to check how many passed quiz 2 only. So we have to add 2 plus 5 plus 4. So we add 2 plus 5 plus 4. And this here is going to give us 11. Then how many took part in quiz 2? So quiz 2, a total of 21 people took part. So we must subtract 21 minus 11 to find only those that managed to pass quiz 2 only. So when we subtract, we get 10. So it means 10 managed to pass quiz 2 only. Then we go to the other part here, which is quiz 3. We check how many passed quiz 3 only. So when we add, we have to add 3 plus 5 plus 4. So when we add 3 plus 5 plus 4, we just get 12. And they're telling us that 27 took part in quiz 3. So we say 27 minus 12. So 27 minus 12, this gives us 15. So meaning 15 managed to pass quiz 3 only. Okay, so now we go on and check if there are people that did not manage to pass any of the 3 what quizzes. So if they didn't manage to pass any of the 3 quizzes, meaning they have to be there in the universal set. So we'll add all these numbers here, then we'll subtract from the total of people that took part, which is 65. So when we add those numbers, we'll get 5 plus 2 plus 5 plus 3 plus 4 plus 15 and plus 10, we'll get 44. So 44, so we do 65 minus 44, we subtract that, then we get 21. So 21 is our answer, meaning 21 here. These did not pass any of these 3 quizzes. These did not pass any of the 3 quizzes. Okay, so now we've illustrated that on the Venn diagram. Now let us answer the question that follows afterwards. So let me just erase this part here. Okay, so erase this such that we look at part 2 of the question. So part 2 says find the probability that a student failed all the 3 quizzes. Find the probability that a student failed all the 3 what quizzes. So we check here how many passed the quizzes, all the 3 quizzes. So we have 5. 5 passed all the 3 quizzes. So how many? Then this is out of a total of 60 what? 65. This is out of a total of what? Of 65 people. So now, meaning the probability that somebody passed all the 3 quizzes is going to be, we divide that 5 divided by 65, and we'll get 0.07, round off that to what? To another 7, like that, 0.077. So this is the probability that what? Somebody passed all the 3 quizzes. And if you are to multiply that by 100, then as a percentage, that is 7.7%. So that's the probability that somebody passed all the 3 quizzes. Now, to check if somebody failed all the 3 quizzes, so these passed all the 3 quizzes, meaning to fail all the 3 quizzes, meaning it's a complement of what? Of this one. The complement of passing all the 3 what? Quizzes. So if we have, the way we are saying, Q1 intersect Q2 intersect Q3, these meaning passed all the 3 quizzes, then the complement of this one is the ones that did not pass all the 3 quizzes. And probability out of a total, we are saying that is going to be 1 minus this complement here. 1 minus that complement there, like that. Okay, like this. So, meaning 1, we have 1 minus, so they're telling us to find the probability that a student failed all the what? 3 quizzes. So we have this number here. Okay, let's just go back to our diagram. This number here, which shows us that these here did not what? Pass any of them, because we have all these here, they passed at least a quiz. So some passed 3, some passed 2, some passed more than what? More than uh, more than 2 quizzes. So now, these here outside did not pass any of the quizzes. So let me just erase this part. Erase this part here. 21, was saying there 21 did not pass any of the 3 quizzes. So those 21 out of our total number is what? 65. These here 21 did not pass any of the 3 quizzes. So we just divide that. We get 21 divided by 65. That gives us 0.32, like that, 0.32. So this is a probability that somebody did not pass any of the what? The 3 exams, because the number outside there is indicating that those there did not pass any of the 3 exams. Yeah. Okay, so this is how you find it. So when you check, at least this one here passed quiz 1. These here in the middle passed quiz 1 and 2. Then we have those there passing quiz 1 and 3, like that, and these passing all the 3. Then those outside there, meaning they did not pass any of these 3 quizzes. So to just find that probability, you say 21 out of 65, those did not pass any of the 3 quizzes. Then we express it as what? As a decimal, that is 0.32. As a percentage, that would be 32%, meaning did not pass any of the 3 quizzes. So that's how you answer these parts 2. Then we have this one, part 3 says find the probability that the student passed at least one of the quizzes. So what you do, you check for the students that passed one quiz. That passed one quiz. So they're saying at least the student managed to what? To pass a quiz. And we're seeing here, we have this one, we have that one there, and we have that one there. These managed to pass at least what? One quiz. So they might have not passed all the quizzes. So when we check here, so at least meaning can be more than what? One, right? So at least. So we have this one there. When we check here, what we have 2, and then we have 3 there. We have what? 4, and then 5 there. So at least means they could have passed one or more quizzes. So find the probability that a student passed at least one of the quizzes. So at least these quizzes that they wrote, at least they passed 1. So these 5 here, 10 and 15, indicates that these passed at least one of the quizzes. They might have not passed all of them, but at least they passed one of the quizzes. So we have 5 plus 10 plus 15. So when we add these numbers here, we get, then here we have to divide over the total number, which is 65. So these at least passed one of the quizzes. That is 10 plus 5 plus 15. That will be 30 over 65. And this gives us 0.46. So yeah, these at least passed one quiz. So this is how you answer this question. Don't know if there are any questions. As a percentage, this could be expressed as 46%. Yeah. All right, so we move on to the next question. We have this question here. It says simplify. We must simplify this. So how do we simplify that there? So when you check the first one, you have root of 54. So root of 54, we can write root of 54 as root of 9 multiplied by 6 minus,
Sorry, sir. I have a question.
yes,
Is this also for 1100? I just joined.
anyone, like they are just math questions, so anyone
Okay.
can join. Yeah,
Okay. Thank you.
sure. Then you have the other part here. You have 24. 24 there we can simplify it as 4 by 6. Because when we multiply 4 by 6, we get 24. When we multiply 9 by 6, we just get 54. And we can write this as root of 9 or root of 6 minus root of 4 root of 6. Then this here, root of 9 is just 3. Then you have the square root of 6 minus here, square root of 2 of 4 is just going to be 2. Then we have the square root of 6. Okay, so here we can then subtract 3 minus 2. Then we will get 1 and we just remain, that will be 1 root of what? Of 6, like this. Of course, 1 multiplied by this is just the same root of 6. So this is how you simplify this question. The next one is here. They are telling us to rationalize the denominator. So we have 4 over 1 minus root over 5. So to rationalize the denominator, you have to multiply both the denominator and the numerator by its conjugate. So if you have 1 minus root of 5, the conjugate of 1 minus root of 5, the sign in between is what's going to change. So you have 1 plus root of 5. So you multiply this, the top and the bottom, by root of 5 over here plus root of 5. And you get, so on top we multiply 4 by 1, we get negative 4 plus, so okay, that will be minus. It will change to minus here. Okay, so that will be minus 4 root of 5. And down there, we will have 1, so it will be 1 squared. That will be 1 multiplying by 1. And of course, when we multiply this, okay, we can expand it throughout. 1 by 1 is just 1, then 1 multiplied by root of 5. That is going to be plus root of 5. Then this negative root of 5 by 1, that would be negative root of 5. Then you have negative this root multiplying by the positive 1. So you get that multiplied by that, this. So on top, you're going to get 4 will be equal to 4 minus 4 root 5. Then down, these here will subtract, you get 0, and you get minus. Then when you multiply that, these will cancel out, and you just remain with 5. So you have 5 there. Then that will give you negative 4. So you have 4 minus 4 root of 5. minus 4. Then you can divide this. So when you divide this, -4, you get there, it will give you 1. Then there to give you plus root of 5. Then this here is going to be your final answer. All right. Then we have this question here. It says express this in the form a over b. So when we have that, this is the same as 0.27 bar like that. Then here, what we must do, we must move this decimal point to there such that uh, we have numbers after the what? After the decimal point. So first of all, we say let x equal to this same number here, 0.2, with a bar like that. This bar means that the 7 and 2 are repeating. Then to move this decimal, it has to move how many times? 2 times, 1, 2. So meaning we have to multiply by 100 on both sides. So I'll get 100x this side, and the other side will be, that will be 7.272 with the bar. Then I can subtract and say 100x minus x is equal to 72.72 bar minus 0.72. From here, what I get is on this side it gives me 99x. Then this other side, this will be this will just be 72. Then I can divide by 99 on both sides, 99. Then I get, okay, so this here will be x is equal to 72 over 99. Then I have to check if I can simplify this. So let me divide. I can divide by 3, both in the numerator and in the denominator, and I'll get that this will be equal to 24 over 99 divided by 3 gives us 33. So you get this there. Then from there, yeah, you can further simplify this. Think by dividing again by 3. So 3 in the numerator gives you 8. 3 in the denominator gives you 11. So this here is going to be your final answer. So you've rationalized this in the form a over b. And from this here, we can see that a and b, so a on top, b down there, these here have no common what? Factors. So which satisfies that this indeed is a rational number. Okay. Then move on to the next question, which we have, which is this one, which is the last question for part 1. Then the question reads, let R be the universal set where you have A as this and B as that. Then they're telling you to find A minus B and display on the number line. So how are we going to do that? So they're telling you that the universal set runs from here negative infinity to positive infinity. Then they're telling us our A is -3 to 4. Then our B is -4 to 2. So we can then plot that. So they're saying -3 to what? To 4. So at -3 it's open. As you can see, our A, it's open here. Interval is open. And also at 4 it is open. And it runs throughout like that. Then we have that our from 4, so 4 here, it's closed at 4. Then all the way up to 2, it is open at 2. Then you can connect this like that. Then they're telling us to find A minus B, or A, the difference of A and B, which is just the same as A intersect B complement. So now you can indicate your complement here. let us sketch our B complement, anything that is not in the set B itself. So this is our set B, that's our set A. So anything that is not in the set B but lies in the universal set. So B here we can see at 4 that B is closed at 4, meaning 4 will not be part of the complement. So it will be open there, going all the way to there. Then here at 2, 2 is not part of B. So if 2 is not part of B, meaning 2 is part of the complement of B. So it will be closed at 2, then going all the way to positive infinity like that. So this is what we have. Then you check now, where does this intersect with the set A? Where is the intersection with the set A? So if I was to drop this dotted line like this down and there, I can see that this here is my intersection. So now my intersection, B here at B, at 2 it is closed, and 2 is part of A. As you can see, it's in the set A, meaning at 2 there it will be closed. Then we're saying it's going all the way here. So 4 is in B complement, but 4 is not in the set A because it's open at 4 there, meaning it can't intersect at that exact point, which means it's going to be open at 4. So A, A, so A into A minus B is just equal to this here, like that. Then you can show this on a number line. You draw it like that. You have goes from negative infinity up to positive there. Then 2, say our 2 is here, and we have our 4 there. So this is going to be closed there at 2, and then all the way up to 4 and open at 4. And this is just going to be A minus B. So that's how you work out this question. I don't know if there are any questions. This is the end of question 1 of this paper.